2 centuries, Professor Richard Whitman said, tapping the chalk once against the blackboard, the sharp sound echoing through the vast lecture hall like a judge's gavel. 200 years of the greatest mathematical minds on earth attempting to solve this problem, and failing. The room settled into a heavy silence as the final line of symbols stretched across the board, white chalk against dark slate, elegant and intimidating at the same time. Rows of graduate students leaned forward in their seats, laptops open, notebooks ready, every eye fixed on the equation that had humbled generations. The lecture hall at Hawthorne Institute was built like a small theater, tiered rows rising steeply beneath bright ceiling lights, the air humming softly with the sound of projectors and whispered anticipation. Whitman stepped aside, gesturing toward the board with quiet authority. This, he continued, is what mathematicians call a graveyard problem. Many brilliant people have entered this territory. None have come back with a proof. A few students chuckled softly, the kind of nervous laughter that came when genius stood too close to intimidation. Whitman smiled faintly, confident, practiced. His reputation filled the room long before his voice did. A Fields Medal nominee, advisor to government research panels, a man whose papers were cited in textbooks across the country. When he spoke about mathematics, people listened the way sailors listen to the weather. Now, he said, folding his arms, the common mistake is assuming symmetry. For 200 years, mathematicians believed symmetry would unlock the structure of this equation. They were wrong. The symmetry collapses the proof every time. Chalk dust drifted slowly through the air as he set the chalk down on the narrow ledge beneath the board. The problem glowed under the lights, beautiful and unsolved. Sometimes, Whitman said, scanning the room, a problem exists simply to remind us of the limits of human thought. The room was perfectly still. No one moved. No one spoke. Not until a hand quietly rose in the very last row. It wasn't dramatic. It wasn't fast. Just a small motion, almost hesitant, like someone testing the weight of an idea before releasing it into the world. A few students turned their heads. Then more. In the back row sat Ava Johnson, a first-year undergraduate who looked younger than most of the students around her. Her dark curls were tied loosely behind her head, a faded gray hoodie pulled over a plain t-shirt, a spiral notebook open on the narrow desk in front of her. The notebook was filled with tight columns of symbols and arrows, pages of quiet thinking that no one else in the room had noticed. Her hand stayed raised. At first, the reaction was confusion. Then someone near the middle rows laughed under their breath. Freshman, another student whispered, not unkindly, just surprised. Whitman squinted toward the back of the hall, shielding his eyes slightly from the lights. Yes, he said slowly. You have a question? Ava's voice carried farther than she expected. Professor, she said, calm but careful, what if the proof keeps collapsing because the symmetry assumption is wrong from the beginning? A ripple moved through the room like wind across water. A few students leaned back in their chairs. One professor visiting from Princeton raised an eyebrow. Whitman studied her for a moment, the faintest smile forming at the edge of his mouth. Miss Johnson. Ava Johnson. Miss Johnson, Whitman said gently, the way a teacher corrects an eager student who hasn't yet learned the rules of the game. If the symmetry assumption were incorrect, mathematicians would have discovered that sometime during the last 2 centuries. A few quiet laughs spread across the lecture hall. Ava didn't lower her hand. Instead, she glanced once at the equation on the board, then back at the professor. Maybe, she said softly. They were all looking in the same direction. The room shifted again, not laughter this time, but curiosity, a subtle tightening of attention as if the air itself had leaned closer. Whitman watched her for a long second. Then he picked up the chalk again and tapped it lightly against the board. Mathematics, he said calmly, doesn't reward guesses. Ava nodded once, almost respectfully. It rewards patterns. For a moment, no one spoke. The equation waited on the board. And somewhere in the quiet back row of the lecture hall, the first crack in a 200-year mystery had just begun to form. Professor Richard Whitman did not respond immediately. He stood near the board with the chalk still in his hand, studying the young woman in the last row as if trying to determine whether he had heard her correctly. The lecture hall held more than 100 students, and in a room filled with future mathematicians, confidence was common. But what Ava Johnson had just done was something else entirely. She had interrupted a lecture about a problem that had resisted 2 centuries of work and calmly suggested that the entire direction of the proof might be wrong. Whitman placed the chalk back on the narrow wooden ledge beneath the board and folded his arms slowly. The movement was calm, deliberate, the kind of motion that told the room the conversation had shifted from lecture to evaluation. A quiet ripple of whispers moved through the rows of seats. Some students glanced back toward Ava again, curious now rather than amused. The visiting professor from Princeton leaned slightly toward his colleague and murmured something under his breath, though the words were too soft to carry across the room. Whitman tilted his head, considering. "Miss Johnson," he said at last, his voice steady but thoughtful, "the symmetry assumption is not a casual choice. It is supported by 200 years of published analysis. Entire journals have been written around that structure." Ava nodded once from her seat, her notebook still open in front of her. The pages were filled with careful lines of equations written in tight handwriting. "Yes, Professor," she replied, her tone respectful. "But those papers all start from the same assumption. If the assumption is wrong, every proof collapses the same way." A few students exchanged glances. One of them closed his laptop slowly, the click of the hinge sounding louder than expected in the quiet hall. Whitman rested one hand on the edge of the desk near the board and looked back at the equation. The symbols stretched across nearly 8 feet of slate, a forest of integrals and operators that represented decades of accumulated work. "And you believe," he said carefully, "that the entire structure fails because mathematicians have been looking in the wrong direction." Ava did not answer immediately. Instead, she looked down at the notebook in front of her, flipping back one page as if checking a detail she had already confirmed many times before. When she looked up again, her voice carried clearly through the room. "I believe the symmetry is forcing the equation into a contradiction that does not actually exist." The silence that followed was different from the earlier quiet. It was no longer the polite silence of students listening to a famous lecturer. It was the silence of people trying to decide whether something unexpected might actually be happening. Whitman exhaled slowly through his nose. For a moment his expression was unreadable, the practiced neutrality of someone who had spent decades standing in front of classrooms. Then he gestured lightly toward the board. "Mathematics," he said, "does not reward confidence. It rewards demonstration." A faint murmur passed through the seats again. Ava hesitated only briefly before closing her notebook. The spiral binding made a soft metallic sound as she lifted it from the desk. Several students turned fully in their seats now, watching her stand. She was smaller than many of the graduate students around her, and for a moment the scale of the lecture hall seemed almost exaggerated, the distance from the back row to the board stretching like a quiet test. Ava stepped into the aisle and began walking toward the front. Her sneakers made soft sounds against the polished floor, each step echoing faintly under the tall ceiling lights. As she moved forward, the room seemed to narrow around the equation on the board. The visiting professor from Princeton straightened in his seat. One student pulled out a phone, not to text but to open the camera. Whitman remained where he was, watching her approach with a look that balanced skepticism and curiosity. When Ava reached the front of the hall, she stopped a few feet from the board. The chalk rested where Whitman had left it, a small white cylinder beside 2 earlier fragments worn down by use. Whitman picked it up and held it out toward her without speaking. Ava accepted it carefully. The chalk felt lighter than she expected. For a brief moment, she simply looked at the equation already written across the board, her eyes moving from one line to the next. Somewhere behind her a chair shifted quietly. Someone else whispered a single word that sounded like wait. Ava lifted the chalk and placed its tip against the slate just beneath the final line of Whitman's proof. The chalk paused there for half a second as she considered the structure one more time. Then she began to write. The first line Ava Johnson wrote was small, almost cautious, a thin trail of white chalk appearing beneath the final line of Professor Whitman's equation. The sound of chalk against slate was soft but clear, each movement echoing faintly through the silent lecture hall. No one laughed now. The earlier amusement had vanished somewhere between the moment she stood up and the moment the chalk touched the board. Ava did not rush. Her eyes moved slowly across the symbols that Whitman had written, then down to the new line she was adding. She erased nothing. She changed nothing above. Instead, she began by writing a small bracket beside the symmetry condition that anchored the entire proof. Then she drew a short horizontal line beneath it and wrote a different constraint directly below. Several students leaned forward in their seats. One graduate student near the middle row whispered quietly to the person beside him, but the whisper stopped halfway through the sentence as Ava continued writing. The difference between the two lines looked small to anyone unfamiliar with the structure, but to a trained mathematician it was unmistakable. Ava had replaced the symmetry condition with an asymmetric boundary constraint. The chalk moved again. Symbols formed beneath her hand in steady rows, each one connected to the next with quiet precision. Professor Whitman remained where he stood beside the board, his arms no longer folded. One hand rested against the edge of the desk while the other touched his chin lightly, his eyes following the line of symbols as Ava extended the equation downward. The visiting professor from Princeton leaned forward so far that his elbows touched his knees. A student in the third row slowly lowered his laptop screen, forgetting to type. Ava paused only once, lifting the chalk slightly as she reread the previous line, then continued writing. The new structure unfolded beneath the old proof like a hidden staircase, where the original equation had forced itself into a contradiction after several steps. Ava's version redirected the path entirely. Instead of collapsing inward, the equation widened, introducing a new variable boundary that allowed the sequence to continue. A faint scraping sound came from somewhere near the back of the room as someone shifted in their seat. No one spoke. Ava finished the next line and stepped slightly to the side so the final section of the board remained visible. The chalk hovered in her hand for a brief moment before she added another line, this one longer than the others, linking the modified boundary to a previously known theorem that Whitman himself had published nearly 10 years earlier. The moment the connection appeared, something changed in the room. It was subtle at first, like the atmosphere adjusting pressure before a storm. The visiting professor from Princeton straightened abruptly. A graduate student near the aisle leaned forward so quickly that his notebook slid off the small desk and landed quietly on the floor. Professor Whitman's hand dropped slowly from his chin. His eyes moved from the newest line back upward through the structure Ava had written, then upward again through the original proof above it. Ava added one final transformation at the bottom of the board, a short chain of symbols that completed the sequence. The equation no longer ended in contradiction. Instead, it resolved into a clean expression that balanced perfectly on both sides. The chalk stopped moving. Ava lowered her hand and stepped back half a pace, the white dust lightly coating her fingertips. The entire lecture hall remained silent. Professor Whitman walked toward the board without speaking. His shoes made quiet sounds against the polished floor as he stopped beside the new section Ava had written. He did not look at her. Instead, he studied the symbols carefully, his eyes tracing the path from the original proof into the new structure. He read the lines once, then again more slowly. His finger lifted and followed one transformation in the middle of the sequence, pausing where Ava had connected the asymmetric boundary to his earlier theorem. Someone in the room finally whispered a single word that sounded like impossible. Whitman's eyes narrowed slightly. He moved one step to the left and read the final line again. For the first time since the lecture had begun, the confident rhythm of the room was gone. In its place was something else entirely. Professor Whitman looked up from the board and turned slowly toward Ava Johnson. Professor Richard Whitman did not speak for several seconds. The entire lecture hall watched him as he stood beside the board, his eyes moving slowly across the sequence Ava Johnson had written. The confident atmosphere that had filled the room earlier had dissolved into something quieter, heavier, like the moment before a verdict is announced. Whitman lifted his hand and traced the middle portion of the equation again, his finger hovering just above the chalk marks without touching them. His gaze moved upward through the original proof he had written, then downward again into Ava's modification, each step connected with unsettling precision. Somewhere near the back of the room, a student shifted in their seat, but the sound faded quickly into the stillness. Whitman finally turned toward Ava. His expression had changed. The faint smile that had carried his lecture earlier was gone, replaced by a focused seriousness that every mathematician in the room immediately recognized. "Miss Johnson," he said slowly, "walk me through the boundary substitution." Ava nodded once. She stepped closer to the board again and lifted the chalk, though she did not add any new lines. Instead, she pointed gently to the small bracket where she had replaced the symmetry condition. The contradiction appears here, she said, her voice calm and clear enough to reach the back rows. Every previous proof assumes the structure must mirror itself across the midpoint. But the equation never actually requires that symmetry. Whitman listened without interrupting. Ava moved the chalk slightly lower along the line she had written earlier. If the system allows asymmetric boundaries, the collapse disappears. The sequence expands instead of folding inward. A murmur passed through several rows of seats as the explanation settled into place. The visiting professor from Princeton leaned forward again, his eyes narrowing as he followed the logic step by step. Whitman's attention never left the board. Ava continued. The contradiction was not in the equation. It was in the assumption. Whitman inhaled slowly, then looked back at the earlier section of the proof above. And the theorem connection? He asked. Ava pointed to the line where she had referenced Whitman's own paper from nearly a decade earlier. Your stability theorem already proves the system holds under variable boundary conditions, she explained. It just was never applied to this structure. The statement hung in the air for a moment. Whitman blinked once, almost reflexively. The realization seemed to arrive not as a shock, but as a quiet alignment, like pieces of a mechanism finally sliding into their correct positions. The visiting professor from Princeton stood up from his seat without fully realizing he had done so. Richard, he said under his breath, though the word carried clearly across the room. Whitman did not answer immediately. Instead, he stepped closer to the board and read the entire sequence one more time from top to bottom. The original proof, the symmetry assumption, Ava's substitution, the expanding sequence, the final balanced expression. When he reached the last line again, he lowered his hand slowly. The equation did not break. It held perfectly. Whitman turned toward the room. For the first time since the lecture had begun, he seemed almost uncertain how to speak. The students watched him with the quiet intensity of people witnessing something that might matter far beyond a single classroom. A graduate student near the aisle whispered to another, "Check the transformation in line 5. The other student flipped open a notebook and began copying the sequence quickly, his pen moving across the page with sudden urgency. Whitman looked at Ava again. "How long have you been working on this?" he asked. Ava hesitated for the first time since she had stood at the board. Her fingers brushed lightly against the chalk dust on her palm. "A few years," she said quietly. The answer caused another ripple through the room. Whitman's eyes widened slightly. "A few years," he repeated. Ava nodded once. "I saw the pattern in a library archive when I was in high school. The papers kept failing in the same place." The visiting professor from Princeton let out a slow breath. Whitman turned back toward the board once more, staring at the final line as if seeing it from a new distance. The lecture hall remained silent. Then, from somewhere in the middle rows, a single pair of hands began to clap. The first pair of hands clapped once, sharp and uncertain, the sound echoing softly beneath the tall ceiling of the lecture hall. For a brief moment no one else moved, as if the room itself needed to confirm what it had just witnessed. Then another set of hands joined, followed by another, and another, until the quiet space that had held equations and disbelief only seconds earlier filled with a rising wave of applause. Ava Johnson stood beside the board, the chalk still resting lightly between her fingers, her eyes shifting between the students and the professors who were now rising slowly from their seats. She had not expected applause. She had expected questions, maybe criticism, maybe silence. Instead, the room responded with the sound that mathematicians rarely offered lightly, the sound of recognition. Professor Richard Whitman did not clap at first. He remained standing near the board, his gaze fixed on the final line of the equation as though it might shift if he looked away. Around him, the visiting scholars and graduate students continued clapping, some exchanging quiet words of disbelief, others already opening their notebooks to copy the proof before the chalk marks could fade. The visiting professor from Princeton approached the board, stopping just a few feet from the final expression Ava had written. He leaned closer, his eyes scanning the structure one more time. "Richard," he said quietly, "the sequence holds." Whitman nodded slowly, though his eyes did not leave the board. The applause continued for several seconds before gradually softening, the energy in the room transforming from celebration into something more focused, more analytical. Students leaned toward each other again, whispering calculations, tracing the steps in their notebooks. One graduate student near the front row turned 3 pages back through his notes and began rewriting the entire structure from the beginning. Whitman finally stepped forward and lifted a small piece of chalk from the ledge beneath the board. He did not erase anything Ava had written. Instead, he added a small bracket beside the final line and wrote 2 careful words beneath it. Verified pathway. The chalk rested there for a moment as he stepped back again. Then he turned toward Ava. His voice, when he spoke, was quieter than it had been at the beginning of the lecture, but every person in the room heard it clearly. "Miss Johnson," he said, "you have just opened a door that mathematicians have been pushing against for 2 centuries. Ava looked down briefly at the chalk dust on her fingertips before answering. "I only followed the pattern," she said. Whitman studied her for a moment, then glanced once more at the board. "Patterns," he replied slowly, "are where discovery begins." The visiting professor from Princeton gave a soft laugh of astonishment. "Richard, you realize what this means?" Whitman nodded again, though his attention remained on Ava. "Yes," he said simply. A student near the aisle raised a hesitant hand. "Professor Whitman," he asked, "does this mean the conjecture is solved?" The room became still again as everyone waited for the answer. Whitman looked back at the board, his eyes moving along the sequence one final time. When he spoke, his voice carried a careful weight. "It means," he said, "that the proof is now possible." Another wave of quiet murmurs moved through the lecture hall. Ava remained standing near the board, her posture calm but thoughtful, as if the moment still felt unreal. Whitman turned slightly toward the audience and placed the chalk back on the ledge. "Ladies and gentlemen," he said, "we may have just witnessed the beginning of the solution to a problem that has resisted mathematics for 200 years. The room absorbed the statement in silence for half a second. Then the applause returned, louder than before, filling the hall with a sound that carried not just excitement, but something deeper, the rare acknowledgement that knowledge itself had moved forward by a single, unexpected step. The applause lingered in the lecture hall long after Professor Richard Whitman had finished speaking, echoing softly against the tall walls before gradually fading into a hum of conversation and rapid thinking. Students who had entered the room expecting a routine academic lecture were now leaning over their desks, scribbling equations into notebooks, and comparing calculations with the urgency of people who knew they were witnessing something rare. Ava Johnson stepped slightly away from the board, placing the small piece of chalk back onto the ledge as if returning something that had never really belonged to her. The board behind her was now filled with 2 centuries of mathematical struggle and one quiet correction that had shifted the entire structure. Professor Whitman remained near the front of the hall, his attention moving between the equation and the young student who had rewritten its direction. The visiting professor from Princeton stood beside him, still studying the lower section of the proof with the kind of focus usually reserved for new discoveries in published journals. A graduate student in the 3rd row raised his hand carefully, his voice hesitant but eager. "Professor Whitman, if the asymmetric boundary condition holds, then the divergent step in line 6 disappears completely." Whitman nodded slowly without looking away from the board. "Yes," he replied, "which means the contradiction was never in the equation itself." The graduate student looked down at his notes again, his pen moving quickly as he recalculated the sequence. Around the room, similar moments were unfolding. Laptops reopened, pages turned, and quiet voices tested the structure Ava had written. The energy in the lecture hall had transformed into something electric but controlled, the feeling mathematicians sometimes described when a problem that had resisted explanation finally began to reveal its shape. Ava stood quietly near the board, her hands resting lightly against the edge of the desk beside her. She did not interrupt the conversation or attempt to explain further. She simply watched the room process the idea she had carried quietly for years. Professor Whitman finally turned away from the board and faced her again. His expression was thoughtful now, the skepticism that had been present earlier replaced by a careful respect. "Miss Johnson," he said, "you mentioned you first noticed the pattern in high school." Ava nodded once. "In a public library archive," she said. "They had old mathematical journals on microfilm. A few students looked up at that. The image of a teenager studying 200-year-old research papers in a public library did not fit the usual story of academic breakthroughs. Whitman folded his arms again, though this time the gesture looked less like authority and more like contemplation. You worked through the structure alone? He asked. Ava hesitated briefly before answering. Mostly, she said. Sometimes I thought I was wrong, because the papers always ended in the same contradiction. Whitman glanced back at the board. They ended there because they started in the same place. The visiting professor from Princeton nodded in agreement. A shared assumption can hide the simplest mistake, he added quietly. Several students began copying Ava's asymmetric boundary condition into their notebooks, testing the transformation themselves. One student whispered to another, "It actually stabilizes the entire sequence." Whitman turned slightly toward the audience again, his voice steady but energized in a way it had not been at the beginning of the lecture. "What Miss Johnson has shown us today is not simply a clever substitution," he said. "It is a reminder that even the most respected assumptions in mathematics must remain open to challenge." The room listened carefully. Ava shifted her weight slightly beside the board, her eyes moving across the rows of students now examining the proof. Whitman looked at her once more, and then at the equation that stretched across the slate behind her. The structure was still the same. The symbols had not changed, but the direction of thought in the room had shifted completely. A moment later, the visiting professor from Princeton spoke again, his voice quiet but filled with astonishment. "Richard," he said, "you realize that if this sequence extends 2 more steps, the entire conjecture becomes solvable." Whitman nodded slowly. His eyes moved to the final line Ava had written. "Yes," he said softly, "and that means the real work begins now." The lecture hall fell into a thoughtful silence again as dozens of minds turned toward the equation, each one exploring the same path that had opened only minutes earlier. The lecture hall no longer felt like a classroom. It felt like the quiet center of a storm of thought. Dozens of notebooks were open now, pages filling rapidly with symbols as students and visiting scholars traced the path Ava Johnson had written on the board. The earlier applause had faded completely, replaced by the focused silence of people who understood that a door had just opened in front of them and that everyone in the room wanted to see how far it went. Professor Richard Whitman stepped closer to the board again, his eyes studying the final transformation Ava had written at the bottom. The chalk marks were simple and precise, but their implications stretched far beyond the 8-foot slate surface. 2 centuries of failed symmetry proofs sat above it like a history of wrong turns. Beneath them, Ava's asymmetric boundary condition had redirected the entire structure. Whitman lifted a small piece of chalk again, but did not write. Instead, he pointed to the final expression. "If the sequence holds 1 more step," he said quietly, "the conjecture no longer collapses." A graduate student in the front row spoke without looking up from his notebook. "It stabilizes the entire function." The visiting professor from Princeton nodded slowly. "Which means the problem was never unsolvable," he said. "It was simply trapped inside the wrong assumption." Ava listened quietly beside the board, her eyes following the conversation as the room processed the shift. The excitement around her did not feel like celebration. It felt like gravity, the kind that pulled every mind in the room toward the same place. Whitman finally turned back toward her. "Miss Johnson," he said, "may I ask you something?" Ava nodded. "When you first saw the pattern, why did you keep working on it?" The question seemed to catch her off guard. For a moment, she looked down at the chalk dust on the ledge beside the board before answering. "Because the contradiction never made sense," she said. "Every paper said the equation had to mirror itself." She glanced briefly at the earlier lines of the proof above her. "But when I graphed the structure, the behavior did not look symmetrical." Several students immediately began flipping through their notebooks again, checking their own sketches of the function. Whitman watched her carefully. "You graphed the equation?" Ava nodded again, using old numerical tables from the archive. The shape kept drifting slightly to one side. The visiting professor from Princeton let out a quiet laugh of disbelief. 200 years of theoretical proofs, he said, and the first person to question them drew the graph. A few students smiled at that, though the humor was mixed with admiration. Whitman looked back at the board again. "Mathematics has a long memory," he said slowly, "but sometimes it forgets to look." Ava said nothing, though her eyes moved again across the line she had written earlier. Around the room, the calculations continued. One student whispered to another, "If the boundary shifts again in the next step, the divergence disappears entirely." Another graduate student had already stood up and moved closer to the board, studying the proof from only a few feet away. Whitman noticed the movement and stepped slightly aside so the students could see the lower section more clearly. The atmosphere in the room had changed in a way that was difficult to measure but impossible to ignore. The earlier hierarchy between professor and student had softened. Now everyone in the room was simply a mathematician staring at the same question. Whitman folded his arms again and looked once more at Ava Johnson. "You realize," he said quietly, "that the next step will determine everything." Ava nodded. "I know." Whitman glanced at the board, then back at her. "Have you tried it?" The room seemed to hold its breath at that question. Ava hesitated for only a moment. "Yes," she said. A ripple of quiet surprise moved through the rows of seats. Whitman tilted his head slightly. "And?" Ava reached toward the ledge again and picked up the same small piece of chalk she had used earlier. She stepped closer to the board and looked once more at the final line she had written. The chalk hovered just beneath it for a moment as she considered the space where the next transformation would go. Behind her, the entire lecture hall watched in silence. Then Ava Johnson began to write again. Ava Johnson lifted the chalk and placed its tip just beneath the final line she had written moments earlier. The entire lecture hall watched in complete silence as the thin white line appeared on the board, extending the structure that had already reshaped 200 years of mathematical thinking. The sound of chalk against slate was soft but unmistakable, a steady scratch that carried through the still air like a quiet signal that something important was happening. Ava did not rush. Her eyes moved carefully across the sequence above, verifying the transformation she had already written before adding the next step. One symbol appeared, then another, forming a new relationship beneath the asymmetric boundary condition that had redirected the proof. A graduate student near the front row leaned forward so far that his chair creaked quietly beneath him. The visiting professor from Princeton folded his arms and narrowed his eyes, following the transformation line by line. Professor Richard Whitman stood only a few feet away, his posture perfectly still, as if even breathing too loudly might interrupt the reasoning unfolding in front of him. Ava paused briefly halfway through the line, lifting the chalk and glancing upward to trace the earlier expressions with her eyes. She adjusted a single variable, then continued writing. The next transformation connected the expanded sequence to a convergence condition that had never appeared in the earlier proofs. It was subtle. Anyone unfamiliar with the problem might have missed the importance entirely. But to the mathematicians in the room the shift was unmistakable. A quiet whisper moved through the middle rows. Someone said softly, "She is stabilizing the divergence." Ava completed the line and stepped half a pace to the right, so the entire expression remained visible. The chalk hovered again as she considered the next step. The board now held 3 layers of thinking. At the top, the symmetrical assumption that had trapped the equation for 2 centuries. Beneath it, Ava's asymmetric boundary condition that had opened the structure. And now, slowly appearing at the bottom, the continuation of the sequence that mathematicians had never managed to reach. Professor Whitman finally spoke, though his voice was little more than a quiet murmur. "If the convergence holds," Ava nodded slightly without turning around. "It does." Then she wrote again. The next line extended the sequence into a compact expression that simplified the entire structure. Instead of expanding into contradiction, the equation folded neatly into a balanced form. The graduate student in the third row stopped writing entirely and stared at the board. The visiting professor from Princeton let out a slow breath through his nose. Ava finished the final symbol and lowered the chalk. For a moment, she simply looked at the result. The equation now stretched across the board like a completed bridge where earlier mathematicians had only built half the span. The contradiction that had ended every previous proof was gone. In its place stood a stable progression leading directly into the solution space of the conjecture itself. Ava stepped back and placed the chalk on the ledge. The lecture hall remained silent for several seconds. Professor Whitman moved toward the board slowly, his eyes tracing the final transformation again and again, as if verifying that the symbols would not rearrange themselves when viewed from a different angle. His finger hovered over the convergent step without touching it. "This eliminates the collapse entirely," he said quietly. The visiting professor from Princeton nodded. "And it extends the proof 2 steps further than anyone has ever reached." Whitman looked up at Ava again. His expression was no longer skeptical, and it was no longer simply impressed. It carried the unmistakable weight of recognition. "Miss Johnson," he said carefully, "if this holds under full review, you have not only corrected the assumption, you have built the missing bridge to the conjecture itself." Ava looked at the board one more time, her eyes following the path from the original proof to the new sequence she had just completed. She did not smile. She simply nodded once. Behind her, the first student began clapping again, slowly at first. This time the sound carried a different meaning. It was not surprise anymore. It was the sound of history shifting inside a quiet lecture hall. The applause returned again, stronger this time, rolling through the lecture hall like a wave that had been waiting for permission to rise. Ava Johnson stood quietly beside the board as dozens of mathematicians and students recognized what had just happened. The board behind her now carried 3 layers of mathematical history. At the top, 2 centuries of symmetrical assumptions that had trapped the conjecture in contradiction. Beneath that, Ava's asymmetric boundary condition that had opened the structure. And now, at the bottom, the continuation that extended the proof further than anyone had ever reached. Professor Richard Whitman remained close to the board, reading the final transformation once more with careful attention. His finger hovered just beneath the convergence step Ava had written. He did not touch the chalk marks. Instead, he followed the logic slowly from the beginning, moving upward through the entire structure until his eyes reached the earliest line of the proof. The room gradually settled into quiet again as the applause faded. Students leaned forward in their seats, waiting for Whitman to speak. The visiting professor from Princeton remained standing near the front row, his eyes still fixed on the equation. Finally, Whitman turned toward the audience. His voice carried the calm authority that had opened the lecture earlier, but now it carried something new as well. "Respect. Ladies and gentlemen," he said slowly. "What we have just seen is not merely a clever extension of a proof." He gestured gently toward the board. "It is a correction to a belief that has guided mathematical research for 200 years. A low murmur moved through the room again as the meaning of those words settled in. Ava stood with her hands resting lightly against the edge of the desk, watching as the audience absorbed the statement. Whitman looked back toward her. "Miss Johnson," he said, "may I ask you something else?" Ava nodded. Whitman took a small step closer, lowering his voice slightly, though it remained clear enough for the entire hall to hear. "When you extended the sequence just now, you did not hesitate. You wrote it as though you had already seen the result." Ava looked briefly at the final line on the board before answering. "I had," she said quietly. Several students exchanged glances. Whitman raised his eyebrows slightly. "You had completed the extension before today." Ava nodded once. "On paper," she said. "Many times." The visiting professor from Princeton gave a soft laugh of disbelief and ran a hand through his hair. "You solved the continuation alone." Ava shook her head slightly. "Not solved," she said carefully. "Tested." Whitman studied her expression. "For how long?" Ava hesitated for a moment. 3 years. The lecture hall reacted with a quiet wave of astonishment. A few students leaned back in their seats, processing the idea that the continuation written on the board had been living in someone's notebook long before today. Whitman looked back at the equation again, his eyes moving across the lower section with renewed attention. 3 years, he repeated. The visiting professor from Princeton stepped closer to the board and pointed toward the convergence step. "If this structure survives peer review," he said carefully, "this changes the entire field." Whitman nodded slowly. "Yes," he replied. "It does." Ava remained quiet beside the board. She had not stepped forward to claim the discovery, and she had not stepped back from it either. She simply watched the room as the realization spread from person to person. Whitman turned toward the audience again. "Mathematics," he said thoughtfully, "does not belong to the loudest voice in the room. It belongs to the person who sees the pattern others overlook." The students listened closely. Some continued copying the final lines of the proof into their notebooks. Others simply stared at the board as if memorizing the moment. Whitman glanced one more time at Ava Johnson and then back at the equation stretching across the slate. "For 2 centuries," he said quietly, "this problem has been considered a monument to the limits of human reasoning." He paused briefly before continuing. "Today, a first-year student walked into this room and showed us that the limit was never the equation." His eyes returned to Ava. It was the assumption. The lecture hall remained suspended in a thoughtful quiet after Professor Richard Whitman finished speaking. The words he had just said seemed to settle slowly over the room like dust after a long journey, each person absorbing the realization in their own way. The equation on the board had not changed. The symbols were the same chalk marks they had been minutes earlier. But now the room looked at them differently. The top half of the board represented 2 centuries of brilliant minds walking the same path toward the same contradiction. The lower half represented a quiet shift that had opened a direction no one had considered seriously before. Ava Johnson stood near the board, calm and still, as if she were simply another student waiting for the lecture to continue. But the room no longer saw her that way. Professor Whitman turned back toward the equation again, studying the final sequence Ava had written. His finger hovered just beneath the convergence step, tracing the path upward once more through the transformation she had introduced. Each line connected with a kind of quiet inevitability. The mathematics did not resist. It did not collapse. It simply held. The visiting professor from Princeton stepped closer to the board again, adjusting his glasses as he reread the final line. The convergence condition stabilizes the entire structure, he said softly. Whitman nodded. Yes, he replied. Which means the conjecture can now be approached constructively. Several graduate students were already working through the implications. One student near the center row had drawn a small graph in the margin of his notebook, testing the behavior of the function under the asymmetric boundary condition Ava had introduced. Another student whispered to his classmate, "It eliminates the divergence completely." Whitman finally turned toward Ava again. His voice carried a careful seriousness now, the tone of someone who understood the responsibility attached to a discovery. "Miss Johnson," he said, "what you have shown today will require careful verification." Ava nodded. "Of course." Whitman continued, "But if the structure survives review, the mathematical community will recognize that this moment began here." Ava looked briefly at the board again, her eyes following the same path Whitman had traced earlier. "It began long before today," she said quietly. Whitman studied her expression for a moment. "Perhaps," he said, "but today is when the rest of us finally saw it." The visiting professor from Princeton turned toward the audience. "Most breakthroughs in mathematics arrive after decades of collaboration," he said. "It is rare to see the turning point happen in real time." A student in the back row raised his hand hesitantly. "Professor Whitman," he asked, "does this mean the conjecture will be solved soon?" Whitman considered the question carefully. He glanced once more at the board, then back at the students watching him. "Mathematics does not move quickly," he said, "even when the path becomes clear." He paused briefly before continuing. "But today we have something we did not have yesterday." The student leaned forward slightly. "What is that?" Whitman turned back toward the board and gestured toward the lower half, where Ava's work began. "Direction." The words seemed to resonate through the room. Ava stepped slightly away from the board now, allowing the students and visiting scholars to examine the equation more closely. Several people stood and moved toward the front rows, their notebooks open as they compared calculations. The lecture hall that had begun as a formal academic setting had transformed into a shared space of discovery. Whitman watched the activity quietly before looking back at Ava Johnson once more. His expression softened slightly. "Miss Johnson," he said, "mathematics remembers moments like this." Ava met his gaze for a second before glancing again at the board filled with chalk and possibility. "I hope it remembers the question," she said. Whitman smiled faintly. "It will," he replied, "because you changed how we ask it." The lecture hall had slowly transformed from a place of formal instruction into something closer to a living laboratory. Students who had originally planned to leave after the lecture were now gathered in small clusters near the front rows, quietly comparing calculations and testing the structure that Ava Johnson had written on the board. Laptops glowed across the room as equations were entered and evaluated. The board itself had become the center of gravity in the room, a wall of chalk that held 2 centuries of mathematical history and a single quiet correction that had redirected its path. Professor Richard Whitman stood a few feet away from the board with his hands loosely folded, watching the room rather than speaking. For the first time since the lecture began, he was not the center of the conversation. The mathematics was. The visiting professor from Princeton had moved even closer to the board and was now tracing the lower portion of the proof with a pencil in his notebook. recreating each step Ava had written. Every few moments he paused and checked the convergence condition again, his eyes narrowing slightly as the structure continued to hold. The stability remains intact, he murmured quietly. One of the graduate students standing beside him nodded. The asymmetry is doing all the work. Ava stood near the edge of the desk, watching the room with the same quiet focus she had shown while writing on the board. She did not move toward the groups of students or attempt to explain the proof further. She simply observed as the idea she had carried privately for years was now being explored by dozens of mathematicians at once. Professor Whitman finally walked a few steps closer to her. His expression was thoughtful, the confident certainty he had displayed at the beginning of the lecture replaced by something more reflective. "Miss Johnson," he said softly, "there is something else I would like to understand." Ava turned slightly toward him. "Yes, Professor." Whitman glanced briefly at the board again before continuing. "When you first noticed the pattern in the archive papers, what convinced you that the symmetry assumption was the real problem?" Ava looked toward the equation stretching across the slate. Her eyes moved across the earlier lines that had formed the traditional proof, then downward to the transformation she had introduced. "Because every proof failed in the same place," she said. Whitman nodded slightly. Ava continued. "The contradiction always appeared exactly after the symmetry condition forced the equation to mirror itself." The visiting professor from Princeton overheard the explanation and turned toward them. "Which means the structure was not revealing a limit," he said. "It was revealing a bias." Ava nodded quietly. "Yes." Whitman let out a slow breath. Around them, the students continued working, comparing numbers, sketching small graphs in the margins of their notebooks. One student near the aisle suddenly looked up from his calculations. "Professor Whitman," he said with visible excitement, "the next iteration of the sequence still converges." The room reacted instantly. Several heads lifted. The visiting professor from Princeton leaned toward the student's notebook and examined the calculation quickly. "Show me the boundary condition you used," he said. The student pointed to the asymmetric constraint Ava had written earlier. The visiting professor smiled faintly. "Yes," he said. "It continues to hold." A quiet ripple of amazement moved through the lecture hall. Whitman turned back toward Ava Johnson. "You understand what this means?" he said carefully. Ava looked toward the board again before answering. "It means the conjecture is no longer unreachable." Whitman nodded slowly. "For 2 centuries mathematicians believed this problem defined the limits of our reasoning." His eyes moved across the chalk marks once more. "Today you showed us that the limit was only a habit of thinking." Ava remained quiet for a moment before speaking again. "Sometimes the pattern is easier to see from the outside," she said. Whitman studied her expression and then glanced at the rows of students still working through the equations with growing excitement. The atmosphere in the room had become something rare, a moment when curiosity and discovery moved faster than authority. Whitman looked back at Ava one final time and said quietly, "Miss Johnson, today you reminded an entire room of mathematicians how important it is to ask the first question again." The lecture hall continued to buzz with quiet intensity. As students and scholars remained gathered around the front rows, their notebooks filling with calculations inspired by the equation that now stretched across the board. The original symmetry proof still occupied the upper half of the slate, its long chain of logic representing the work of generations. Beneath it, Ava Johnson's asymmetric boundary condition and extended sequence had reshaped the entire structure into something alive with possibility. Professor Richard Whitman stood slightly to the side now, no longer guarding the board as the authority in the room, but observing the mathematics as it unfolded among the students. The visiting professor from Princeton had already begun copying the entire proof from the top line to the final convergence expression, speaking quietly to a graduate student beside him. "The extension continues to stabilize the structure," he said while checking the transformation once more. The graduate student nodded quickly, turning another page in his notebook. Ava remained near the edge of the desk, watching as the room worked through the implications of the proof she had quietly carried for years. She had expected questions earlier in the lecture, perhaps a brief conversation, perhaps skepticism. Instead, the idea had expanded outward like a spark touching dry paper, spreading across dozens of minds at once. Professor Whitman finally stepped closer to the board again, his eyes tracing the equation with careful patience. After a long moment, he picked up a fresh piece of chalk and added a small notation beside the convergence condition Ava had written. He did not alter the proof. He simply marked the point where the structure began to hold. The chalk made a soft sound as he placed it back on the ledge. Mathematics will spend years studying this moment, he said quietly. The visiting professor from Princeton looked up from his notebook. It may spend decades. Whitman nodded. Yes. A student standing near the aisle turned toward Ava, his voice filled with cautious excitement. Did you ever think this would happen in a lecture hall like this? Ava smiled faintly, though her expression remained thoughtful. I thought someone would eventually see it, she said. The student glanced back at the board. I do not think anyone expected it to happen today. Whitman turned slightly toward the audience again, the tone of his voice steady but warm. Every field has moments when its direction changes, he said. Most of the time. Those moments happen quietly inside research papers or long collaborations. Occasionally they happen in a room full of witnesses. The students listened carefully. The visiting professor from Princeton closed his notebook and rested it against the desk as he studied the board again. Richard, he said slowly, 2 centuries of work will now be rewritten. Whitman looked at the upper half of the board where the traditional symmetry assumption still remained. Not rewritten, he replied. Understood differently. Ava's eyes moved across the board again. The old proof did not disappear. It simply revealed the place where it had gone wrong. Whitman turned toward her once more. Miss Johnson, he said gently, I suspect the mathematical community will want to read the notes where you first developed this idea. Ava nodded. They are in a spiral notebook, she said. Several students smiled quietly at that image. Whitman returned the smile. Then I believe that notebook may soon become one of the most important documents in modern mathematics. The lecture hall slowly settled into a calmer rhythm again as students resumed writing and discussing the proof with growing confidence. The excitement had not disappeared, but it had matured into something deeper. A shared recognition that knowledge had moved forward by a single step that none of them would forget. Whitman looked one final time at the equation filling the board. The symbols had not changed, yet their meaning had expanded beyond the room. He then turned back toward Ava Johnson and said quietly, sometimes the greatest discoveries do not come from louder voices. They come from someone willing to question the oldest assumption in the room. The lecture hall slowly returned to a quieter rhythm as the discussions settled into focused conversations. Some students were still gathered near the board, carefully copying the final structure into their notebooks before the chalk marks could fade. Others had returned to their seats, reviewing calculations and sketching small graphs beside the equations. The excitement that had filled the room earlier had not disappeared, but it had transformed into something steadier. It felt like the calm that follows a moment when everyone realizes they have witnessed something rare. Ava Johnson stepped slightly away from the board and rested her notebook on the desk beside her. The chalk lines behind her still stretched across the slate in 3 clear layers of mathematical history. At the top, the symmetry assumption that had guided 2 centuries of research. Beneath it, the small substitution that had opened the structure. And finally, the extended sequence that carried the conjecture forward into solvable territory. Professor Richard Whitman stood quietly near the center of the room, his gaze still fixed on the board. For a long moment he said nothing. The visiting professor from Princeton had finished copying the proof into his notebook and closed it gently, as if sealing a moment he knew would be remembered. A few graduate students were still testing the convergence condition on their laptops, quietly confirming that the sequence continued to stabilize exactly as Ava had shown. Whitman finally turned back toward the audience. His voice was calm, but it carried a tone that felt different from the beginning of the lecture. It carried humility. Ladies and gentlemen, he said slowly, today we expected to study a problem that has resisted solution for 2 centuries. He glanced briefly toward the board again. Instead, we learned something much more valuable. The room listened carefully. Whitman looked at Ava Johnson before continuing. We learned that even the most respected assumptions must remain open to question. The students remained silent, absorbing the moment. The visiting professor from Princeton nodded quietly. Ava looked once more at the board, her eyes tracing the path from the first line of the proof down to the final expression she had written only minutes earlier. It did not look dramatic. It was simply mathematics. symbols arranged in the correct order. But those symbols now represented a new direction for an entire field. Whitman stepped closer to the board one final time and placed a small box around the final convergence line Ava had written. He did not add any additional symbols. The box simply marked the place where the path had changed. Then he placed the chalk back onto the ledge and turned again toward the room. Mathematics does not belong to titles, he said quietly. It belongs to anyone willing to see what others overlook. A few students nodded softly. Ava picked up her spiral notebook from the desk and held it against her side. She did not step forward for recognition, and she did not step away from it either. She simply stood there as another student in a room full of people who loved the same language of numbers. The visiting professor from Princeton walked past the board slowly and paused beside Ava for a brief moment. "You know," he said with a quiet smile, "people will talk about this lecture for many years." Ava looked back at the board one last time before answering. "I hope they talk about the question," she said. The professor nodded thoughtfully. Across the room, the students were still studying the equation, some whispering to each other as they worked through the final steps. Professor Whitman watched them for a moment, then allowed himself a faint smile. The lecture had begun as a demonstration of a problem believed to be impossible. It ended with a room full of mathematicians seeing possibility instead. And at the center of it all, a young student who had simply raised her hand and asked the question that 2 centuries had forgotten to ask.